Hi Mr. Donatelli. This is my second video and let's start to do it. The problem says determine the acceleration of either box and the table is frictionless. So let's say we want to determine the acceleration of the 3 kilogram box. So the first thing we need to do is the free body diagram. Which has three forces acting on it, that is force of tension, normal force, and force of gravity. And we also have to do the coordinate system, which goes like this. We do our chart and we record all of the forces going in the x and the y direction. We see that in the x direction the box is moving in the right direction, so it's positive because of the coordinate system. We also have normal force and force of gravity in y direction. As we know that the box will not move in the y direction, only in the x direction, we know that the net force is equal to Ft, and applying the second law of Newton, that says that net force equals mass times acceleration, we replaced it, and since we know that mass equals 3, we already have this equation to see what is the acceleration of the 3 kilogram box. The next step is to find what is the force of tension. To find this, we have to find our components in the 4 kilogram box. So we do the free body diagram. We know we have force of tension going up and force of gravity going down. We do the coordinate system, which goes this way, the opposite as this one. And since there's only forces going in the y direction, we can record the forces that are acting upon it. So we see that F net x equals Fg minus Ft. And we know that Fg is equal to mass times gravity, which is equal to 4 times 9.8. So we know 39.2. And we replace F net x by our second law of motion, max equals 39.2. And we just isolate for Ft. And question is to do some algebra and substitution to find what is Ax. So now we know our answer, and it is 9.8 meters per second squared. I hope you understood.